So now we will discuss about determining the RMS and average values of AC signals. So before I start on the problems, let's have a quick look on the formula for determining the RMS and average values. Let us suppose there is a signal which is having a time period, the time taken for completion of one cycle. It is given by T. In other words, the frequency, which is F, both are related by, and the signal is given in this format. The pattern of the signal is given for you, and I'll assume that it is periodic in nature, which is having a repetitive pattern. In that case, the average value is determined by using the formula 1 by T integral 0 to T f of t dt. Whereas RMS value is determined using the equation, the same equation I am writing again, but the roots and the mean square. Right. So now if a pattern is given for you, then you can determine the average and RMS values. Now that how we will do that we will see now. Now let us suppose, try to remember this formula. I am moving on to a problem. Now let us suppose there is a pattern which is given for you. Okay, and it is continuing. Okay. Now this is a sawtooth waveform. Okay, and this is given for you. Now on careful observation, you can observe that this is the time period, because after this period it is repeating. So your time period is 2 seconds. Okay, this is time, whereas this is magnitude or amplitude. Time in seconds. So T is 2 seconds. Now during this one complete cycle, if you carefully observe what pattern it is following. It is following a straight line, and after that it is coming back to 0. Again after that taking a straight line, again getting back to 0. So it is important. The first step is determining the time period. The second stepping is determining the mathematical equation. Determining the mathematical expression. This is most important. Okay. Now, before that, how many parts are there? There is only one part. This is defaultly. So, from this is your V of t, which varies from 0 to 2. It is having a pattern of a straight line, which we need to identify. And at 2, it is coming back to 0, and again it is following the same pattern, right? So I'll ignore this one. At 2, it is 0. But whereas from 0 to 2, it is following a straight line. So how to determine the equation of a straight line? See, this point it is 0, 0, whereas this point it is 2, 2. You need to draw a straight line which passes through these 2 points. You know the equation, y minus y1 by y2 minus y1 is equal to x minus x1 by x2 minus x1. So here, this is x1 y1, this is x2 y2. So this is y minus 0 by 2 minus 0. This is x minus 0 by 2 minus 0. So I'll get y is equal to x. Right. So in this case, y coordinate is my voltage, x coordinate is my time. So I'll write it as v is equal to t. Right. So this is the mathematical expression which governs these 2 zones. Now the third one is determining the average value. So its equation is 1 by t, 0 to t, f of t dt. what I should do is I should separate these time periods into different intervals based upon these things. So here I can write from 0 to 2, it is f of t dt, and f of t is t dt, and the other one is again it is 0. For this entire thing I should do. So if you do it, what you will get? So this is t integral, I'll get t square by 2, and this is 0, I don't get an integral. This t square by 2 is to be done from 0 to 2. The overall capital T is t, right? So I'll write it here, it is 1 by t integral, it was 0 to 2 t dt, isn't it? So this is t square by 2 from 0 to 2 plus 0. So if I do it, this is 2 square by 2 minus 0 square by 2 plus 0. So what I'll get as 1. 4 by 2, this is 0, 0, this is 4 by 2, 2. 2 by 2 is 1. So this is my average value. And if I go with the RMS value, it is the same, but the fact is that this will be squared, right? So the same 2 appears here, again here, from 0 to 2 it is t square, instead of t it is t square, from 2 to 2 it is 0 square. So if I do this one, integral t square dt from 0 to 2 plus 2 to 2 0 dt, right? So what is the integral for this one? It is t cube by 3 from 0 to 2 plus this is 0, no change. So if I substitute it, what I'll get? This is 2 cube by 3 minus 0 cube by 3 plus 0. So this is 8 by 3. Already 1 by 2 is there. So it is 8 by 6. So it is 1.33. This is your VRMS value. And this is the way how you determine the average value and RMS value of a waveform. Okay. So we will see some more problems now in the next class.